Have you ever wondered what our bones are made of? This thought has probably crossed your mind at some point. Our bodies, after all, are complex structures that rely heavily on these hard, robust elements. Bones, remarkable as they are, play a tremendous role in our lives. They provide support, protect our organs, store and release minerals, and even facilitate movement. The fascinating world of bones is indeed a wonder in itself, full of untold mysteries and marvels. Today, we delve into the fascinating world of bones, exploring their composition, microscopic structure, and function. Bones are not just rigid structures, they're dynamic, thriving tissues consisting of numerous components, each serving a unique purpose. The outermost layer of the bone, prominently known as the periosteum, performs a crucial role as it houses blood vessels, nerves, and lymphatic vessels. These components are responsible for nourishing the bone, ensuring its health, vitality, and fortitude. Following the periosteum is another layer, the compact bone. This is a highly dense and stiff layer providing immense and structure to the bone, acting as a shield from external pressure and potential injuries. But the essence of the bone lies deep within these layers, in the spongy bone. This area, rich red and yellow bone marrow, performs the critical function of producing blood cells, thus maintaining our body's overall health. It also serves as a storage house for fat. Deep within these layers lies the spongy bone, filled with red and yellow bone marrow, responsible for producing blood cells and storing fat. On a microscopic level, bones are marvels of nature's architecture. They are intricate formations, masterpieces in their own right. At their core, they bear compact bone, a complex structure that beholds the finest details. Its composition lies in the tiny units referred to as osteons. These structures, minute yet significant, consist of concentric layers that tell a story of resilience and strength. This matrix is a blend of collagen and calcium phosphate, materials crucial for our body's functioning. At the center of each osteon, a canal resides. It houses the essentials, blood vessels and nerves. Bones play a crucial role beyond providing a skeletal framework. They are vital for more than just their structural function. These rigid organs enable us to move efficiently by providing pivot points for muscles. They safeguard our internal organs from external impacts. Additionally, they take on the important task of generating blood cells, essential for life. Moreover, they work as a storage area, preserving minerals like calcium and phosphorus. This storage function allows the body to maintain mineral balance, vital for numerous physiological processes. The scapula, or shoulder blade, is a flat, triangular bone that connects the upper arm to the collarbone. It's one of the 3 bones that comprise the shoulder girdle and plays a crucial role in the movement of the arm. To the forearm, you'll find 2 bones called the radius and ulna. The radius is situated on the side of thumb, providing support and strength. Conversely, the ulna is positioned on the side of the little finger, acting as a stabilizing force. Understanding these and their alignment is crucial to appreciating the complexities of human anatomy. The humerus, the long bone in the upper arm, connects the shoulder to the elbow. The hip bone, also known as the pelvis, is a fundamental structure in our anatomy that plays a pivotal role in supporting and safeguarding our vital internal organs. It not only provides a sturdy base for the spinal column, but also houses formations like the sacrum and coccyx, forming a protective cage around certain organs. Transitioning from the hip, we come to the femur, a bone that holds the title for being the longest and strongest bone in the human body. This impressive structure extends from the protection of the hip all the way to the knee joint, acting as a key component in our mobility. Below the knee, we meet the tibia, often referred to as the shin bone. This bone, the larger of the 2 found in our leg beneath the knee, plays a critical role in supporting our body weight and facilitating movement. The tibia, also known as the shin bone, is the larger of the 2 leg bones located below the knee. A typical rib is a flat, curved bone whose primary role is safeguarding the vital organs nestled within the chest. Just think about it. Without these strong, curved bones, our lungs and heart would be left exposed to potential harm. Now let's shift our attention to the vertebra. Vertebrae, the small irregular bones, form the crucial part of our spine. These bones, though small, have an exceptional role. Their duty is to ensure the protection of our spinal cord. This cord, a delicate structure, is the pathway for nerves that transmit signals from the brain to the rest of the body. A typical vertebra, part of the spine, is a small, irregular bone that protects the spinal cord. The skull, the body's most complex bony structure, houses the brain and sensory organs, providing a sturdy shield of protection from external harm. This multifaceted structure plays a pivotal role in human physiology and anatomy. Composed of 22 intricately interlocking and immovable bones, the skull includes, among others, the cranium, a dome-like formation that secures the brain, and various facial bones. These bones not only shape our appearance but are also vital for functions like eating and communication. It consists of 22 bones, including the cranium and facial bones. To recap, we've explored the composition and microscopic structure of bones, as well as their function. We've delved deep into the cellular layers and structures that make up various bones, including the scapula, which, with its complex plate-like structure, supports your shoulder and arm. We've explored the radius and ulna, two parallel bones in your forearm that work in unison, rotating and flexing to give your wrist its range of motion. The humerus, a long bone in your upper arm, was another subject of our exploration. It plays a crucial role in arm movement and stability. The hip bone, an essential part of the pelvic region, was closely examined too. Its unique structure provides support to the body's weight and protects the internal organs. Our journey of discovery also took us to the longest bone in the human body, the femur. This bone is not only responsible for bearing the body's weight, but also plays a vital role in locomotion. The tibia, a large bone lower leg, was also part of our investigation. Primarily weight-bearing, the tibia works in harmony with the fibula to provide stability and support. We didn't ignore the seemingly smaller bones either. The ribs, with their curved structure, provide a protective cage for our vital organs. The vertebrae, each one uniquely shaped, form an integral part of the spinal column, housing the spinal cord and supporting the body's structure. Lastly, we just scratched the surface of the skull bones, which protect brain and are the very foundation of our face and head structure. Each bone, regardless of its size, whether as large as the femur or as small as the vertebra, plays a crucial role. They work in unison to support us, protect us, and even help us move. So the next time you take a step or reach for something, take a moment to appreciate the complex symphony of bones at work.